Hello students of class 10. This is General Maths chapter 3 pair of linear equations in two variable. Okay. So linear equations in two variable you have already learned in class 9. Okay, you have already learned in class 9. So you see pair of linear equations in two variable. Recall from class 9 that the following are examples of linear equation in two variable. 2x plus 3y is equals to 5 and x minus 2y minus 3 is equals to 0. Okay, and x minus 0y is equals to 2, that is x is equals to 2. Okay, so these are examples of linear equations in two variables. Okay, these are examples of linear equations in two variable. You also know that an equation which can be put in the form of ax plus by plus c is equals to 0, where a, b and c are real numbers and a and b are not both 0, is called a linear equation in two variable x and y. Okay, you have also studied that a solution of such an equation is a pair of values, one for x and the other for y, which makes the two sides of the equations equal. For example, let us substitute x is equals to 1 and y is equals to 1 in the left hand side of equation 2x plus 3y is equals to 5. Then LHS is equals to, I get 5, which is equals to the RHS of the equation. Therefore, x is equals to 1 and y is equals to 1 is a solution of the equation 2x plus 3y is equals to 5. Now let us substitute x is equals to 1 and y is equals to 7 in the equation 2x plus 3y is equals to 5. Then LHS equals to, I will get 23, which is not equals to the RHS. Therefore, x is equals to 1 and y is equals to 7 is not a solution of the equation. Geometrically, what does this mean? It means that the point 1, 1 lies on the line representing the equation 2x plus 3y is equals to 5, and the point 1, 7 does not lie on it. So every solution of an equation is a point on the line representing it. Okay. In fact, this is true for any linear equation, that is, each solution xy of a linear equation in two variable ax plus by plus c is equals to 0 correspond to a point on the line representing the equation and vice versa. Now consider equations 1 and 2 given above. These equations taken together represents the information we have about Gita at the fair. These two linear equations are in same two variables x and y. Equations like these are called a pair of linear equations in two variables. Let us see what such pairs look like algebraically. The general form of a pair of linear equations in two variables x and y is a1x plus b1y plus c1 is equals to 0 and a2x plus b2y plus c2 is equals to 0, where a1, b1, c1, a2, b2, c2 are all real numbers and a1 square plus b1 square not equals to 0 and a2 square plus b2 square not equals to 0. Some examples of pair of linear equation in two variables are 2x plus 3y minus 7 is equals to 0 and 9x minus 2y plus 8 is equals to 0. 5x is equals to y and minus 7x plus 2y plus 3 is equals to 0. X plus y is equals to 7 and 17 is equals to y. Do you know what do they look like geometrically? Recall that you have studied in class 9 that the geometrical, that is graphical representation of a linear equation in two variables is a straight line. You have learned in class 9. Okay, it is very important that a linear equation, if you represent a linear equation geometrically or that is graphically, yes, what you will get? You will get a straight line. Understand? That means a linear equation represents a straight line, okay, on a graph. Can you now suggest what a pair of linear equation in two variables will look like geometrically? There will be two straight lines. As there are two equations, okay, that is only a pair of linear equation. A pair means what? There are two equations. Understand? So you will get two straight lines, both to be considered together. You have also studied in class 9 that given two lines in a plane, only one of the following three possibilities can happen. The two lines will intersect at one point. The two lines will not intersect, that is they are parallel. The two lines will be coincident. Okay, so it is a pair of linear equation. Okay, pair of linear equation in two variable. If you take one linear equation, okay, if you take one linear equation and represent it graphically, you will get a straight line. As there are two linear equations, okay, as there are two linear equations, so you will get two straight lines. If you represent these two linear equations in two variables in graph, you will get two straight lines. Understand? So either the two straight lines will intersect at one point, either they will be parallel, or the two lines will be coincident. Okay, the two lines will be coincident. We saw all these possibilities. They intersect, they are parallel, they are coincident. Okay, next you see here. So these are given, either they intersect, the two lines will intersect at one point, that they will be parallel, or they will coincide. Understand? So next, these are examples there. Exercise 3.1 I have already given you in notes. Okay, so 3.3 you see graphical method of solution of a pair of linear equations. Okay, graphical method of solutions of a pair of linear equations. So now in here you see, okay, figure 3.2, you noted that the equation representing the situation are geometrically shown by two lines intersecting at point 4 and 2. Okay, so therefore point 4 and 2 lies on the lines represented by both the equation x minus 2y is equals to 0 and 3x plus 4y is equals to 0, and this is the only common point. Understand? So in here you see there are two equations, x minus 2y is equals to 0 and 3x plus 4y is equals to 0. Understand? And these two equations will represent two lines. Okay, these two equations will represent two lines graphically. Okay, if you represent these two equations on a graph, you will get two straight lines. Now what it is saying that these two straight lines intersect at a point, and the point is 4, 2. Understand? These two straight lines, they intersect at one point. Understand? And that point, it is what? It is 4, 2. What is the coordinate of the point? 4, 2. Understand? So you see, since 4, 2 is the only common point on both the lines, therefore both the lines, there is one and only one solution for this pair of linear equation in two variables. Understand? So that is what it is saying, that you see, if you take this equation and if you represent it on a graph, you will get a straight line. And again, if you take this equation and if you represent it on a graph, then again you will get two straight line. You will get a straight line. Now these two straight lines, they intersect at one point. Yes, they intersect at one point. Understand? So, and this is the only common point. Understand? This is the only common point. Understand? So these two equations, okay, these two equations has one and only one solution. Understand? These two equations has one and only one solution, and that solution is their intersection point, which is 4, 2. Okay, so thus the number of rides Geeta had on giant wheel is 4 and the number of times she played hoopah is 2. In the situation of example 2, can you find the cost of each pencil and each eraser? In figure 3.3, the situation is geometrically shown by a pair of coincident lines. The solution of the equations are given by the common points. Okay, are there any common point on these lines? From the graph we observe, okay, figure you see 3.3. Figure 3.3, yes, this is the figure 3.3. You see in here what it is going on. So these two equations were there, and when I represented these two equations on the graph, what happened is that I got these two lines. Okay, the lines represented by these two equations, you see they have drawn only one line. That means what is going on is that these two lines are drawn on top of each other. Understand? These two lines are drawn on top of each other. Understand? And this is called that the two lines are coincident. Understand? These two lines are coincident. And when two lines coincide, yes, when two lines coincide, you see this is a straight line, and on this straight line, how many points can you draw? On this straight line, how many points can you take? There are infinite number of points, yes, as this is a straight line, and there are infinite number of points, and each of those points are solution. Each of these points are solution of these two equations. Understand? Are solutions. Each of these points are solution of these two equations. So therefore it is said that when two lines, understand, when two lines coincide, then these two equations have how many solutions? Have infinitely many solutions. Understand? Have infinitely many solutions. Now if the two, for example, like in here you say, this one you see, in here the two lines intersect at only one point. The two lines intersect at only one point. Understand? That means these two equations have only one solution, or you can say unique solution. Understand? Have only one solution. And what is the solution? It is this 4, 2. Understand? X is equals to 4 and y is equals to 2. Okay. And in this type of situations where the two lines are coincident, in here the two equations have infinitely many solutions. And this type of equations where the two lines are parallel, they are not intersecting, they are parallel. In this type of situations, the two equations have no solution. Understand? Because intersection point only not there. Okay, so in this condition, when the two lines are parallel, there is no solution. Understand? So now you see, as you have already learned, that when a pair of equation have infinitely many solution, when a pair of equation has unique solution, and when a pair of equation have no solution. Understand? Have only one solution, then the two lines will intersect at one point. Okay, infinitely many solution, that means the two lines are they are coincident line. Understand? And if there are no solution, that means the two lines are parallel. Okay, now you see, a pair of linear equation which has no solution is called an inconsistent pair of linear equation. Okay, a pair of linear equation which has no solution is called an inconsistent pair of linear equation. A pair of linear equation in two variable which has a solution. Okay, a solution, one solution is there. Understand? A pair of linear equation in two variable which has a solution is called a consistent pair of linear equation. And a pair of linear equation which are equivalent, okay, pair of linear equations which are equivalent has infinitely many distinct common solution. That means infinitely many solution. Understand? When the two linear pairs are equivalent. Okay, for example, you see, for example, this is x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 is equal to 0. These two equations are same equations only. Understand? Because from here, if I take 2 common and if I send it to the right hand side, then I will get this equation only if you look nicely. Sorry, there is a slight mistake. What they have done, it is 2x plus this is figure 3.3. Oh, sorry, one thing. Example 3 graph is this one. Okay, example 3 graph is this one. Figure 3.3, for this the equations are these two equations. Okay, these two equations. For figure 3.3 I was showing you, okay, figure 3.3 I was showing you these two equations. Understand? Actually these two equations are for figure 3.4. okay, these two equations are for figure 3.4, and for this graph the two equations are these two equations. Understand? So you see these two equations, if I represent them in graph, then what I am getting these two lines and they are coincident. Yes, these two lines and they are coincident. Understand? And these two lines are what? And these two lines, you see, it is 2x plus 3y is equals to 9 and 4x plus 6y is equals to 18. These two equations, since they give coincident lines, that means these two equations are same. You can look here nicely. If I take 2 common and send it to right hand side, I will get this equation only. Understand? These two equations are equivalent. Therefore, their geometrical representation gives me coincident lines. Understand? Okay, that one I was saying that these two equations are for this graph. I was showing these two equations are not for this graph. Okay, these two equations are for this graph. Understand? So these two equations are not equal. Okay, these two equations are not equal. So therefore in here you see it is saying that a pair of linear equations which has no solution is called an inconsistent pair of linear equation. Okay, a pair of linear equations which has no solution is called an inconsistent pair of linear equation. Understand? No solution, that means these pair of linear equations gives me parallel lines. Okay, therefore they have no solution and they are called inconsistent pair of linear equation. A pair of linear equations in two variables which has a solution is called a consistent pair of linear equation, and a pair of linear equations which are equivalent has infinitely many distinct common solutions. Such a pair is called dependent pair of linear equation in two variables. Note that a dependent pair of linear equations is always consistent. Understand? We can now summarize the behavior of lines representing a pair of linear equation in two variables and the existence of solution as follows. Okay, now you see first one, the lines may intersect in a single point. In this case the pair of equation has a unique solution, that means consistent pair of equations. The lines may be parallel. In this case the equation have no solution, inconsistent pair of equations. The lines may be coincident. In this case the equations have infinitely many solutions, dependent pair of equations, and dependent pair of equations is always consistent. Okay, now let us now go back to the pair of linear equations formed in exercise 1, 2 and 3 and note what kind of pair they are geometrically. These two equations, you see these two equations, if you draw them in a graph, the two lines will intersect. These two equations, they are both same equations only, therefore their lines will coincide. And these two equations, they are parallel, that means they have got no solutions. Understand? Now you see, looking at this equation, how will you know that their lines will intersect, coincide, or they will be parallel? So this one it will give me from this box. So you see pair of lines, these two are pair of lines. Now this one you see, if I do A1 by A2, understand? You see in here, so first one you see, this is x minus 2y is equals to 0 is equals to 0 there. Okay, now linear equation in two variable, it takes the form of a1x plus b1y plus c1 is equals to 0 and a2x plus b2y plus c2 is equals to 0. Understand? If you compare it in here, if I do a1 by a2, okay, if I do a1 by a2, what I will get in here? I will get 1 by 3. Okay, if I do b1 by b2, I will get minus 2 by 4, which is minus 1 by 2. And c1 by c2, in here c1 is 0 there, so 0 by minus 20, okay, which is equals to 0. Understand? So now in here you see what I got in here, it is that a1 by a2, it is not equals to b1 by b2. Understand? a1 by a2 not equals to b1 by b2. Understand? So since a1 by a2, this is our important here, since a1 by a2 not equals to b1 by b2, that means these two lines, understand, if these two linear equations, if you represent it geometrically or graphically, understand, these two lines, what will happen, these two lines, understand, these two lines, it will intersect at a point. Understand, these two lines, it will intersect at a point. Okay, so these pair of linear equations, you will say they have exactly one solution or unique solution. Understand, exactly one solution. Understand, exactly one solution. Okay, if a1 by a2 not equals to b1 by b2 there, then the two lines will intersect at a point and they will have exactly one solution. Understand? Now next, I will just show you the conditions now. You see, first of all, this is very important. a1 by a2 not equals to b1 by b2 there. Okay, a1 by a2 not equals to b1 by b2, then their graphical representation will be the two lines will intersect at a point. Understand? And algebraic interpretation will be they have exactly one solution. Understand, they have exactly one solution, and this solution will be this point of intersection will be their solution. Understand? Next, it is if a1 by a2 is equals to b1 by b2 is equals to c1 by c2 there. Understand? That means their graphical representation will be, they will be coincident lines. Understand? They will be coincident lines. Okay, they will be coincident lines. Okay, and since this line has infinitely many points in here, since these lines will have infinitely many points, so therefore they will give me what? This one coincident lines. Okay, this one intersecting lines, this will be coincident lines. Okay, coincident lines, and it will give me infinitely many solutions. Okay, it will give me infinitely many solutions. Okay, infinitely many solutions. Understand? And next it is, if it is that I have got a1 by a2 is equals to b1 by b2 not equals to c1 by c2 I got. Understand? a1 by a2 is equals to b1 by b2 not equals to c1 by c2 I got. Okay, then their graphical representation. Understand, their graphical representation, what I will get? Their graphical representation, I will get that the two lines will be parallel. Understand, the two lines will be parallel. They will never intersect at a point. The two lines will be parallel, and it will be parallel lines. It will be parallel lines. Okay, and how many solution they will have? They have no solution. Since these two lines, it does not intersect only, so they have no solution. Understand? They have no solution. In this chapter, this one only means for your you see, for exercise 3.2, this is only the most important thing. Understand? So next it is again one more thing, it is that you see if the lines intersect at one point. Okay, if the lines, for this is the case, a1 by a2 not equals to b1 by b2, they intersect at a point. Understand? Then the pair of linear equation, okay, I will say that they are consistent pair of equations. Okay, another one thing is there, that the pair of linear equations will be consistent. Understand? This is a consistent pair of, let me write it in here, this will be consistent pair of equations. Understand? Consistent pair of equations. Okay, next it is if the lines are parallel. Okay, if the lines are parallel, then I will say that they are inconsistent. Okay, I will say that they are inconsistent. Okay, inconsistent pair of equations. If the lines are parallel, then I will say that inconsistent pair of equations. Now if in a question it is asking that check whether the pair of linear equations are inconsistent, so you will have to take out this one, a1 by a2 is equal to b1 by b2 If you get that it is not equal to C1 by C2, that means the two lines are parallel. They have no solution. So therefore you can say that the pair of linear equation in two variable is inconsistent. Understand? And next it is if the lines may coincide. Okay, if the lines coincide, this is the case. In this cases, how many solution does the pair of linear equation in two variable has? Infinitely many solution. Understand? And they are called dependent pair of equations. Understand? They are called dependent. Okay, dependent, or bracket it is consistent given, consistent pair of equations. Okay, dependent. If you see, if exactly one solution, that means a1 by a2 not equals to b1 by b2, then you will say that consistent pair of equations. Understand? If this one, if the lines coincide, that means a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Understand? C1 by C2, then infinitely many solutions. That means dependent pair of equations. Understand? And it is said that dependent pair of linear equation is always consistent. Okay, dependent pair of linear equations is dependent pair of linear equations is always consistent. Okay, and if the condition is this, a1 by a2 is equal to b1 by b2 not equals to c1 by c2, that means you know that the two lines are parallel, they have no solution, and they are called inconsistent pair of equations. Understand? These things you will have to remember. And the next exercise 3.2, it is all about this only. Okay, exercise 3.2, question number 7, I think I have not given. Question number 7 I will give it in a separate note. Okay, so this chapter, it is about pair of linear equation in two variable. How to solve a pair of linear equation in two variable, it is already I have given you. Okay, the three methods I have already given you: substitution method, okay, substitution method, elimination method, and cross multiplication method. Understand? I have already given it to you. And next are this is a pair of linear equation in two variable. If you draw them graphically, then you will get two straight lines. Understand? Now these two straight lines, they can intersect at a point, they can be coincident, or they can be parallel. If they intersect at a point, then the pair of linear equations have exactly one solutions, and they are called consistent pair of equations. And if they are coincident, understand, if they are coincident, then they have infinitely many solutions, and they are called dependent pair of equations. And if the lines are parallel, understand, then the pair of linear equations have no solutions, and they are called inconsistent pair of equations. Understand? Now how will you know that the pair of linear equations will intersect at a point? If you get this one, a1 by a2 not equals to b1 by b2, understand, then you will know that the pair of linear equation will intersect at a point. If you get that a1 by a2 is equal to b1 by b2 is equal to c1 by c2, that means the pair of linear equation will be coincident. And if you get that a1 by a2 is equal to b1 by b2 but not equals to c1 by c2, that means the two lines will be parallel and they will have no solution. Understand? So this chapter, it is about this only. This is the most important thing. Understand? You will have to remember. Understand? And if you this one, let's say a pair of linear equation in two variable, it is given. Okay, for example, you see, let me check this examples. You see, check graphically whether the pair of equations is consistent. Understand? I have to check it graphically. So if so, solve them graphically. Okay, so in here these two equations are there, so you will have to draw a box in this way. Understand? In here you give x you give, and y, you say y. From this equation I can take out the value of y. X I will send it that side, I will get 6 minus x, and by 3 I will get, yes, y is equal to 6 minus x by 3. So now in here you see x value, if you give 0, if you x value 0 if you give, then what I will get? 6 minus 0 by 3. 6 minus 0 is 6. 6 by 3 I will get 2. If you give x value 6, then y value you will get 0. Similarly for this also, x you take and y you find out. Okay, and put a value of x and y value find out, and put another value of x and y value find out. Understand? Now this is the value of x, this is the value of y, this is the value of x, this is the value of y. Understand? This two will give you the coordinate points, means they are the coordinate points. Understand? So this is like that, you graph you draw. Understand? So first one you see x0, then y2, x0 then y2, this is the point. And next it is x6, then y0, this is the point. So these 2 points you draw the line. Okay, these 2 points with the help of scale draw the line in such a way that this line will have to pass through these 2 points. Okay, draw the line. If you want, you can write the equation. Understand? This line represents which equation? It is this, the first one, x plus 3y is equal to 6. So they have written it. Understand? And similarly for the next equation, you see x value 0 given, then y value 4 got, x value 0 then y value 4, this is 1 point. And x value 3 given, x value 3 given, then y value minus 2, this is the point. Yes, now we will draw a line that will pass through these 2 points. Understand? And since I have drawn it, you can see here that these two lines they intersect at one point, which is 60. Understand? That means 60 is the solution of these 2 equations. Understand? 60 is the solution of these 2 equations. In this way you can represent pair of linear equations in 2 variable graphically. Okay, now you see these two lines, they intersect at a point. So if 2 lines intersect at a point, then they are called what? Consistent pair of equations. Understand? Means consistent pair of equations. That means this one, consistent pair of equations you got. So these 2 lines intersect at one point, that means they have a unique solution. Understand? You see, they have got unique solution. Understand? So with this, your chapter 3, which is pair of linear equation in 2 variable, it is over. Some of the questions I have not given in the notes, you please try by yourself. Understand? You please try by yourself. So with this, your chapter 3, it is over. If you have any doubt or any topic I will have to explain again, you please write it in the comment section. I hope you have understood. Thank you.